Hey everyone, welcome to this video on Concept 5 Continued. We are going to continue talking about our building blocks of geometry, but today we're going to talk about some more symbols and markings in geometry. So start off with a little bit of review. Congruent segments, we've already talked about them. Two segments are congruent if and only if they have the same length or measure. So we can just draw a quick example. If I have a line segment, and then I have another line segment. If they have the same length, I would mark them congruent. We learned about those marks the other day. Okay, and the midpoint is a point that bisects the segment or divides the segment into two congruent parts. So if we have a line segment, and if the midpoint is right there, then it bisects it, it cuts it in half. So those are two review vocabulary words. Okay, so on to some new vocab. Congruent angles. Two angles are congruent if and only if they have the same degree measure. So if I have an angle, and then I have another angle, let's say maybe this is 25 degrees, and then this one is 25 degrees. These would be congruent, and we're going to mark them with a similar marking as the segments, but we're going to draw an arc and draw a little hash mark through that arc. We're going to draw an arc and then a hash mark through it. So sometimes you could have double hash marks or triple hash marks depending on how many angles you have in the picture. Another way to show congruent angles, if these two were congruent, is to show the same number of arcs. So you could have double marks, triple marks, or single marks to represent that they're congruent that way also. So there's two different ways you can do angles. You can do an arc with a certain number of hash marks. So you could have like 2 hash marks, 3 hash marks, 1 hash mark, or you can just look at the number of arcs and match them up that way. So an angle bisector is a ray that bisects the angle or divides the angle into two congruent, oh gosh, that should say angles there. I'm not sure why it says points. Let's change that into two congruent angles. So if we have an angle, and then if we have another ray that comes right from the endpoint down the center, that would be our angle bisector, and it's dividing it into these two congruent angles. So this is the angle bisector. So it's sort of like a midpoint, but for angles. Okay, so just a couple of notes here at the bottom. The symbol for congruence is this here. It's sort of a combination of an equal sign with that wavy symbol on top, which we're actually used for similar. We'll talk about that later in the year. So you might say something like angle A is congruent to angle B. So you say, when you read it out loud, you would say is congruent to instead of is equal to. Or we don't have a shorthand like for equal, we can just say equals. We don't say congruence. So you just have to read angle A is congruent to angle B. We use the equal symbol between equal numbers. So you might use that in a situation where if we look at these two angles here, I could say the measure of this angle is equal to the measure of this angle. So if we're talking about the measure of it, that's referring to the degree number. And we're going to talk about how you would write that in a second. We'll look at some examples. So we use the equals symbol between equal numbers, and we use the congruent symbol between congruent figures. So if we're talking about congruent squares or congruent line segments or congruent angles, we use the congruent symbol. If I'm talking about the measure of them, the side length of them, the angle measure of them, that's when I'm going to use the equal sign. And we'll talk through a lot of examples of this. Okay, so here we're going to look at a couple of examples of how we use the congruence and equal symbols. And I just noticed every now and then when I take a Word document and change it to a PDF, some symbols change and don't stay the same. And here's an example of them. This should not be an @ symbol. That should be a congruent symbol. It's just weird how it does that. It does it sometimes, but not all the time. Where over here, this one stayed just fine. Anyway, in this picture, we have a triangle, and you can see that the side length of AB has 4 centimeters, and the side length of AC also has 4 centimeters. That means that line segment AB is congruent to line segment AC. Notice the bar on top that we talked about last time to show that it's a line segment. But then we can also say, because they're both 4, that the measure of AB, we put the M in the front to show the measure of AB, which is referring to the 4 centimeters, is equal to the measure of AC. So this is talking about a number. That's why we have the equal sign. Where these are referring to a geometric figure, a line segment, and that's where we use the congruent symbol. Here's another example. In this picture, in this triangle, we see all of these marks, and they match up with the marks over here. So we can see, for example, here's a single, and here's a single. Here's a double, and here's a double. Here's a triple, and here's a triple. And then the same thing for the angles. You can see single, double, and triple marks to match up. So just one example is that angle BDC is congruent to angle WYX. So that's this angle right here, angle BDC, that matched up with angle WYX. So that angle, because they're referring to geometric figures, it's an angle, they're congruent. Well, this statement is a different one because we have an equal sign here. So this is saying that the measure, and this should have an angle mark here, the measure of angle BDC is equal to the measure of angle WYX. So now we're referring to the actual degree measure, whatever that was. Because they're congruent, that means the degree measures are the same, so we can now use the equal statement. The measure of angle BDC is equal to the measure of angle WYX. So again, this is referring to a number, right? These are numbers. The numbers are equal, then whatever the degree measure is, 30 degrees, 25 degrees. This is just saying that the angles are of the same size. The angles are congruent. So the geometric figures are congruent. The measures of them, the numbers are equal. So let's write a few statements down here using congruent and equal for each diagram. So in this first one, we've got these two are matched up. You can look at the different hash marks and angle marks in the pictures. So there's so many we could write. Let's maybe just write a couple for each one. So we could start by saying angle A is congruent to angle D. Remember, it's okay to have just one letter there because it's not confusing about which angle A we're talking about. This is the only angle A that there is. But you could also have said angle BAC or angle CAB to talk about that angle. But angle A is enough. So angle A is congruent to angle D. But I could also say that the measure of angle A is equal to the measure of angle D. Okay, on the right, here we have, just looking at one triangle, because of these marks, we can see that those two line segments are congruent. And then I also have the angles are congruent. So what I would like for you to do is just pause the video for a second, and I want you to write two statements, both about these two line segments. I want you to write it about this line segment and this line segment. I want you to tell me that they're congruent and tell me that they're equal, and then come back and check it. So pause it, write it, and then come back. Okay, so this is what you should have. Something like AC is congruent to BC, and then the measure of AC is equal to the measure of BC. Don't forget your bars on top for those line segments. So you want to have these on the top since all of these are line segments. Okay, so here's a few more symbols that are really useful in geometry. This first one says, the same number of arrow marks indicates that lines are parallel. The symbol, like those two sort of forward slashes, or they can be straight up and down, means is parallel to. So in this picture, we can see that line P is parallel to line Q. Here's the statement telling us that. And in the picture, these symbols are showing us that. Again, like the other marks we've seen, you could see just single marks, like those single little marks. You might see triple, you could see more than that, but it's the same number of them on each line to show that they are parallel. All right, the second one, a small square in the corner of an angle indicates that it measures 90 degrees. This symbol means is perpendicular to. It's an upside down capital T, and that's a universal symbol. So you can use these symbols in your notes on a test, and everybody knows that they mean parallel and perpendicular. So here's just one example. It doesn't have to always be where they intersect all the way through like this, and you don't have to always draw all 4 of those right angle marks. But that's just one example. We'll see a couple more in a second. And here is a statement just saying line M is perpendicular to line N. So you can see down here, we have one where it's not intersecting all the way through, and that's okay. That's just another way to show perpendicular lines. And then here's another one where we're only seeing one angle. So we're going to write some statements for each diagram using the parallel or perpendicular symbol. So in the first one, we could say, because we see these single marks here, I can say that line AD is parallel to line BC. I could also say that line AB is parallel to line DC. Okay, and then in the second one, we have perpendicular going on because of the right angle. So these are line segments, so we can say that line segment MN is perpendicular to line segment AB. Okay, why don't you write the statement for the last one, and we'll come back and check it in a second. Okay, so here we had rays, and we can see that ray NS is perpendicular to ray NO. So hopefully you got your rays in the right order, with N coming first because N is the end point, and your symbol on top heading to the right. So ray NS is perpendicular to ray NO. Okay, so our last vocab word here is skew lines. What I would like for you to do is pause the video and read this section, like read these statements and look at the picture. And then here's another thing you can read through and see if you can get a picture in your mind of what skew lines are. Just want to see if you can think about it on your own before I tell you. So just pause it a couple minutes, and then when you're ready, come back and we'll talk about it. Okay, so hopefully you have an idea about what skew lines are, but if you're still a little confused, what I want you to do now is write this down, 2 lines that do not blank, but are not blank, and see if you can fill in those words. So pause the video again and see if you can think about what goes in those 2 blanks, and then we'll come back and talk about it one more time. Okay, so skew lines are 2 lines that do not intersect, but are not parallel. So the only way to think about skew lines is it has to be in the 3-dimensional world. Skew lines don't exist in 2 dimensions. We can have 2 lines that are parallel in 2 dimensions. We can have 2 lines that intersect in 2 dimensions, but we can't have them that don't intersect and are not parallel. So these 2 lines that I've highlighted, PS and QX, you can see that they're never going to touch. They're never going to intersect, but they're not parallel. They're not running side by side. They're not equidistant apart at all points. So that is what skew lines are. This other example up here of the picture is a really good real world example of skew lines. Now, obviously these lines don't remain straight forever, but in this moment, those 2 lines are skew, and that's how we can have a highway over top of a road without having car accidents, right? So they're skew. They're in 2 different planes. So skew lines end up having to be in 2 different planes. It's how they exist by default, and they don't intersect, but they're still not parallel. So I just want you to think about your space that you're in right now and see if you can look around and find 2 examples of skew lines. If you're in your bedroom or in your living room, all you have to really do is look at maybe the vertical line on a dresser, or the vertical line up and down on a chair or a table or a countertop. If you have that line, and then maybe look for the line where the wall in your room meets the ceiling at the top, and that's going horizontal. Those 2 lines would end up being skew. They're not going to intersect as long as the piece of furniture wasn't right underneath that line. So just try to see if you can find 2 lines that you know in your room are not parallel but do not intersect, and just describe them on your paper. Just write down which lines you're talking about. You can just say like vertical line of my chair and the horizontal line where my wall meets the ceiling, or whatever. So take a few minutes and write down 2 different examples of skew lines that you can see in the space that you are in.